Hello and welcome to this lesson on percentage by mass. In today's lesson, we will focus on one lesson objective: determining the percentage by mass of an element in a compound. Understanding how to calculate the percentage by mass will enable us to better understand the proportion of elements present in compounds, which is crucial for various real-life applications in fields such as material science and industrial chemistry. To finish the lesson, we will look at some practice questions. Let's get started. The percentage by mass of an element represents how much of the compound's total mass is made up of that specific element. This gives us an idea of the element's contribution to the compound. This is best understood with an example. So, let us calculate the percentage by mass of magnesium, Mg, in magnesium chloride, MgCl2. The calculation for percentage by mass of an element is the total relative atomic mass of the atoms of that element divided by the relative formula mass and multiplied by 100. Let's see how we apply this to our example. To begin, we need to determine the relative formula mass, molar mass, of the compound. This is done by adding up the relative atomic masses of all the atoms in the compound's formula. We know from the periodic table that magnesium, 1 Mg, has a relative atomic mass of approximately 24. We can also see that chlorine, Cl, has a relative atomic mass of approximately 35.5. Thus, the relative formula mass of MgCl2 is 24 for Mg plus 2 multiplied by 35.5 for the two Cl atoms. This then gives us 24 plus 71, which equals a total of 95. So, if we turn back to our equation, we now have 95 as our relative formula mass. Now, let's work out what percentage of 95 does the magnesium account for in MgCl2. This is achieved by multiplying the element's relative atomic mass by the number of times it appears in the compound's formula, also known as the number of atoms of an element in the compound. There is one atom of magnesium in the formula MgCl2. Therefore, the mass of magnesium in 1 mole of MgCl2 equals 1 multiplied by 24, which equals 24. Now we can put the mass of magnesium into our equation. Now we divide the mass of the element by the relative formula mass of the compound and multiply by 100% to find the percentage by mass. This gives us 24 divided by 95, multiplied by 100%, which approximately gives us 25.3%. So, the percentage by mass of magnesium in magnesium chloride is approximately 25.3%. This step-by-step method can be applied to any compound to find the percentage by mass of an element within it. By following these steps, we can systematically determine the contribution of a specific element to the overall mass of a compound. Let's dive into some GCSE level questions to apply our understanding of calculating the percentage by mass of an element in a compound using the relative formula mass, molar mass, and the relative atomic masses of the elements present. Question 1. Calculate the percentage by mass of chlorine in sodium chloride. First, we begin by calculating the relative formula mass, molar mass, of NaCl. If we look at the periodic table, we know that this is 23 for Na plus 35.5 for Cl. This gives us a total of 58.5 for our relative formula mass. Given that there is only one atom of chlorine in this compound, we can just divide 35.5 by 58.5. Next, we multiply by 100. This then gives 60.68, which is approximately 60.7%. Now, let's calculate the percentage mass of sodium in sodium chloride instead. From our previous question, we know that the relative formula mass of sodium chloride is 58.5. We can also see that there is only one atom of NaCl, giving sodium a total mass of 23. We can then fill in our equation. This gives us 23 divided by 58.5, multiplied by 100, which equals 39.31, which is approximately 39%. Now, let's calculate the percentage by mass of oxygen in carbon dioxide, CO2. We know from the periodic table that the relative atomic masses are 12 for carbon and 16 for oxygen. Let's start by calculating the relative formula mass of CO2. We do this by adding the relevant masses. Therefore, 12 for the carbon plus 32 for oxygen, since there are 2 oxygen atoms. This gives a total of 12 plus 32, which equals 44. To find the percentage mass of oxygen, we need to put 32, again, since there are 2 oxygen atoms, over 44. 32 over 44 multiplied by 100 equals 72.72, which is approximately 72.7%. Now, let's calculate the percentage by mass of carbon in CO2. We have the relative formula mass of CO2 from our previous question. We need to recognize that there is only one atom of carbon in the formula CO2. Therefore, we can put 12 divided by 44 multiplied by 100, which equals 27.27, which is approximately 27.3%. These examples clearly demonstrate how to calculate the percentage by mass of an element in a compound. By following the steps, you can tackle any similar GCSE level questions with confidence. In today's lesson, we delved into the concept of calculating the percentage by mass of an element in a compound by dividing the total mass of the specific element in the compound by the relative atomic mass of the entire compound, and then multiplying by 100. This formula helps us determine the proportion of each element in a compound, which is crucial for various chemical calculations and practical applications.